Hello, hello. All right, so we'll start off with assessment task 2. I released it last night. Okay. Sorry about my voice. I'm a little bit have a cold, so possible try to stay away from me in the tutorial. Try to stay away. Just go for the other tutor. Yeah. So this is just a slide just to highlight the specs that I released. Okay, so we can get the chance to talk about a little bit. So this is, I divided into themes, okay, but theme is just provide you with some guide of where you can go. As you probably listened to my talk before, a lot of our works go everywhere. It's not just game, not just entertainment, so this is just opening, but you can do education, you can do health, things like that. So, but this is not a limitation, so they just simply tell you that actually just feel free to explore other things, okay. So these are big areas, so you don't actually have to worry. So essentially, your work here will just pick from one of these themes, okay, individually. By the way, you can work. I wouldn't say how to put this. You can work together, okay, but not work for each other. So you can kind of brainstorm, get ideas. So you might work on a similar project, but actually different solution. Okay, I think I mentioned this before. So don't feel like you're strained that you can't talk to others, because with 85 students, there's very little chance you don't talk. So it's most likely you will talk anyway. So I just want to get it clear. So you can feel free to bounce idea around your team. As I said before, don't go too far. Don't go to the fact that you just simply wait and copy your work to your friend to submit your work, and that would be both bad for you and for your friend. So no matter who actually copy who, but both of them would not end well, okay? So just make sure of that. So try to get your idea. I think some of you already have ideas, okay? Just pick some of those things. And the tool that you will experience today in the tutorial is really much, I wouldn't say much easier, but much simpler to learn. It's webcam. You can do this on your laptop that have the webcam, something like that, or you can do with a phone. If you have the phone, you can port it in the phone. So those are kind of very simple augmented reality components, so you can do that. So the theme here, you can do a multiple combination of themes, okay? So that means it could be mixed between things. Notice I throw an entertainment at the bottom, okay? That is just in case that either you really like playing games, or you just simply have no idea else. You just kind of land, oh, maybe I make some games. So, but either way, I mean, this is just indicative. Okay, it's not limit. Okay, you can go out of it, but at least in your report, you need to identify what theme you're approaching, yeah, even though it may not on this list. Okay. What you want to avoid is that your report start out like, this is what I'm doing, but instead of that, instead of what it should be, you should tell that, okay, this is a theme I'm working on, this is a problem inside my theme, and you try to go from the design component. So the key one is actually a design of interface. Okay, what's the interface role? As some of you already submit on, hopefully working on assignment 1, which is due tonight. Okay. Is that you probably want to look at how the interface, significance of interface. So this one is exactly get it from the assignment 1. Is that how is important is the interface is in this, what you try to do here as a prototype. So that means assignment 1 is a precursor for this one to get you thinking in that sense. Okay, the second one here is the developments. Okay, I highlight that term because it will not be good if you just simply download and then from someone else and then submit it. Okay, so even though you can download that, okay, you can download other people's work except your classmate. You can download that, but then you have to make your own little, big, small of your own. So that's why the development means you do need to develop a little bit of things. Okay, it can be copy and paste and then finish. Okay, so but development work here is a very big kind of fussy term. Okay, as I said in the tutorial before, you don't need to. Is it a bird? Oh, okay, okay, real. I thought it was my cold was flying up. All right, so is not about developing from the bottom code up. Okay, even though tutorial yesterday, some of you might go as far to the end of tutorial to the list on my Milo that actually go all the way and look at the C# code. But this is not my intention to have everyone try to start from there, because that usually take few months, few years to try to get up from that stage. So for this course, it's really about using what's already available, but customize them. Okay, you probably understand customize, changing. Like yesterday, the field, for example, is a bunch of a virtual world with wall, castle, right? That you play with. You can remove that, replace with a model, things like that. So that's the class as some part of the developments. Okay, so in that case, that you have to try to work it out, how your controller will work, what the interaction will look like. Okay, so you can see development here should be indicative of what you try to do in the design. So the second paragraph should come from the first paragraph. If you look at my design guideline yesterday, which we will look at it again in the second half of this today lecture, so on that one, it's basically flow through that part. Okay, and when you submit here, if you look at the spec carefully, we ask you only submit not the whole Unity project, okay, because we don't want a lot of file coming to us, and we don't have time to look inside your code. However, we do reserve the right. If we suspect that there's something kind of, or we just want to see it, we will send email to individual and ask you to resubmit the source code that you've done the project. But for this project, for this assignment, as you read through, is basically you just submit what we call the build version. If you're familiar with the developments, so basically you build either if on PC platform, you will build like Oculus, you will build exe.exe, which is a typical desktop application Windows. Okay, and if you develop on mobile device, you have to submit the APK, okay, application package, okay, which we can download into our phone and then test it. We're just looking at the end product. However, that doesn't mean that if we suspect there's something funny happening, that this is really not far beyond what the student should be able to do within this period, then we might ask you, okay, we might ask you to submit your source code, okay, but hopefully we don't do that, okay, but it doesn't mean anything. Sometimes we could be impressive. We just want to see your source code. Yes, this is just some kind of caution that. Don't just submit anything because grab somebody else's final outcome. It's easy. Yeah, it's easy. For example, if the 85 come in and we realize the two projects are exactly almost identical, then we don't know who is doing what, right? So what that means is that we suspect that it might be something going on. So we ask both of you or both of the person to submit the code. And when we make the judgment that who copy who or whether anything funny going on, then we ask you to show us how your codes work. And that when you show the real people who do it will actually have more understanding of it. Mm-hmm. So just be careful of that. Okay, I also put it in the specs. Okay, and this one is, I think I talked quite a bit. Okay, so the idea here is that because before it used to be whatever you develop, you write about that. Okay, so that is always until the last few years when we realized that actually your report it could go better, it could go wider and more in depth in the design, but you actually limited yourself with what you have. Okay, so that's why I break these two apart. Okay, so the technical development is part of the whole project, but the whole project that you write in your report, in this case, is 1,000 words, which is about 2.5 pages of text. So that one you can actually talk a little bit more beyond, not much more. In this case, it's like you can talk much more than what the technical size that you actually managed to achieve. Okay, so that is actually, if you don't feel like you can do much here, so you can just do just indicative. Okay, it might be in an extreme condition. This is a library example. Okay, so for example, you want to create a virtual library which has 3-story tall building inside a different sector. You might just create one corner of it, and the rest of it is actually described in the report. Okay, how the interaction will work, and some of the interaction you want to, like talking to virtual avatar, those kind of things, it could be something like that. You might be able to implement it, but you can actually definitely write in the report. Okay, but your development cannot just be a box in the Unity running, so you should be some corner, some book, something like that. It kind of might not even be a room in this example, just one room, but building a virtual room is no trivial task. To make it realistic, it's actually, you have to get in a lot of things. Okay, like model this room. If you start for, you don't have any modeling background, then it could take you semester. It's not. So that means that it might just be a corner that had a bookshelf, and you think, oh, this is a way to do it, just like a mock-up. Yes. Mm-hmm. Yeah. So hopefully you get some idea. You get the idea. Okay. I think at the end we talk about the scope, the criteria. Okay. This is just try to tie to what we talked about yesterday. Okay. So as you see here, yesterday we covered about the first four. Okay. Identify what when you identify the theme that you want to work on, like education, you have to identify what the problem are in that field. Okay. That interface can help. Then you move on to the second one. So when you write a report, it goes stream like that. Okay, into a step. And then, of course, this one, as I said before, typically you will try to solve the problem with whatever technology available. But in this case, you don't have many technology available to you. So in some way, you do need to have one eye looking at, okay, it could be AR, VR stuff, to see what AR can do. So it will work backward a little bit. Okay, but I think it's the whole story here has a flow. Okay. And then storyboarding, we talk about that. This one could be hand drawing, no need graphic, hand drawing, take a picture, dump it in your report, and that would do. As long as I can see it. I think there's a phone call for me. Oh, sorry, I think I need to pick up this phone call. Just so this one storyboard, just as I said before, everything kind of like that. So you draw it on the floor, or you can do graphic, whatever you fit. Okay, as long as it actually came out on the report, it looks okay. It's okay. Okay, and then, but this one went further. That's what the part of technical components that you have to develop some proof of concept that basically along the line of what you're projecting in the report. Okay. So you don't just submit something that actually had nothing to do with what you actually propose in the report. Okay. So in some ways, it's built into the same train. Okay. Any questions? So for this step here, you would not need to do any of this. This is for assignment 3. Okay. Even this is not that much. Okay. So assignment 3 here, you will ask your colleagues, your classmates, to review your program. Okay. Just quickly, they can give you a one sentence, it looks good, things like that. So something simple like that. Okay? And then basically, you just address in the report how you want to plan the change. But you won't have a time to make a change, but you address them anyway. But for assignment 2, you don't have to worry. Just make sure your prototype somewhat working. Okay. So remember, this is just try highlight. So now you have a hardware, experience hardware for the last couple of days. Okay? Firmware and all the problem that we have with Oculus, and then the software itself. Okay, so this is something that actually you're dealing with now, which is the Unities and all these things. Okay, so hopefully you pick up. And one thing that I should have, I didn't think that I have to do this, is that your learning in this unit should not stop when you're not seeing my face. So it should go beyond the class, because this is really intensive unit. So basically, you should just take out all the time, that not just when you see my face and you're learning. So because that won't be enough. Okay. And this is where you try to come up with a design. Design in our course here, in architecture will mean something else, in arts will mean something else, but in our unit, design here is really interaction design. It's really about 3D interaction design. If you're going to use the VR, then why would you use this kind of interface? What kind of interface would be applicable? Why would it justify for that? Okay, so that's something that you have to focus on. Okay, and that's why I don't see a problem if you don't have a strong background in. Most of you don't have a strong background in hardware. Some of you will have some background in software, but none of that is really the big issue for the unit. The big issue is whether you can actually see the design through. Okay. All right, so that's just try to bounce this off to my diagram here. Okay, so this is what we're talking about here. So now you understand a little bit what technology that you available to you is, which is not just what you're going to learn today and what you have learned in the last couple of days. Okay, and now it's really you pick a theme and you try to design what experience you want to do. So this is really about solving certain problem that you think they have. Okay, so it's probably best. It's ideal case that you actually find the problem that you think this could improve. They don't actually need to have a problem, but you just need to convince yourself the technology can improve that. Even though they're doing okay, but you can improve them. Okay. All right, so criteria here, this is in a big shot. Okay, so are you familiar with the criteria reference? I'll show on Milo in a second, but this is basically break down into this one. So this assignment that due today is 10% of your total unit. A final exam is 50%. Okay, this one is 20. Assignment 3 is another 20. Okay, so within the 20, this is what it breaks down to, evenly. Okay, so application description. Okay, whether you understand what you try to do, how well you articulate what the purpose of your applications are. Generally, if you have a clear idea, this is a snap. It's not a big problem. Interaction design, this is where your creativity will come in. How much you want to do, things like that. Which area you want to, how you see the problem, how you apply the problem, whether the existing technology you have in hands is actually fit with what actually the problem you select. Okay, so those are kind of things that actually going to be play a part in number 2 there. Okay. Technical development, I think we all go through the similar things. Some that have more technical background, you can get this part relatively easy. You look at my criteria, I spent a heap of time last night trying to knock it down so that it's actually easy for marker to do. If it works, then it practically moved you to either distinction or HD in that category. If it doesn't work, then we determine whether how bad it's not working. and 3D models, so this one we haven't talked about much, but you probably will know I forgot to add some online resources. I do that in the tutorial this afternoon. This is how you download the models and how you create your own contents. Okay, if you like to, some people tend to like to create a content as themselves, but you have limited time. So what that means is that you might end up importing this from the website and dump it into your Unity scene. Okay. For example, you can move all this castle wall from the example yesterday, take it all out, put something else that you found that is actually fit with your theme, and put inside your Unity, and then that's it. That becomes the model. But if someone that really, really want to do modeling, there are 3ds Max sitting around in that lab, so you can actually use that. Okay. It will become in bigger play when in assignment 3, when you actually have few people. You can have one people model, do programming, those things like that. But assuming that each one has something to offer, otherwise you'll be kind of working in the same stream, like similar to assignment 2. Okay. And of course, report. Okay. Report here is really how to address it. Mostly the report here is really not the whole report, it's how you write them. Okay. Whether you have a lot of errors, a lot of typos, a lot of this. So usually this part is not really super strict for me. Usually if you're decent, write with convictions in your writing, usually get HD relatively easy. But for international students, sometimes we have issues with typo and those kind of things, so you might drop to credit distinction, this area. But the other areas are really evidence-based. Okay, that one is really as good as what you actually do. Okay, let me pull quickly on Milo here. Just give me a second. So hopefully now you're active on Milo. Everyone should be now. So, and I can actually tell who actually not logged into my unit Milo when the last time each one of you logged into the Milo. Although you can fool the system by having logged in on, but actually work on something else. But I can tell you that actually if you're missing for long, okay. All right, so this one, oh, did I? Oh, I should just go with my, I don't have to pretend to be a student to see what you would most likely see. So you see this one is a spec, okay, come with that. Unfortunately, due to the time to the spring unit, this one is actually just around the corner. I think some of you probably already started. Okay, you definitely need to start this toward the end today. Okay, so because assignment 1 is relatively the easiest one. I think you can try to finish this off, but to get idea in assignment task 2 is actually you should start now. Start today before even I say assessment task 1. You can do this, finish this by yourself. But you might need some help in assessments too, because you need to get the technical components up. So I think in tutorial today, you should focus on assignment 2, what to do, what to learn, and try to go forward with that. Even though you're not quite finished assignment 1, because you can still finish after the tutorial. You can just get writing only. Yes, so that part is relatively easy. That's what I would suggest. So this one is actually online. Okay. So a lot of these, so 20%, about 1,000 words. So there's a questions on limitation of words here. Usually I'm not really strict, okay? So that means as long as it's plus or minus 10% within that range is okay, okay? So so you dump me it's 2,000 words, I might just scratch my head and say, okay, so which part should I read here? And you just drop me, 500 words, and okay, so you really don't have anything else to say here. So I mean, you have to balance those parts, okay? Even though you might not feel confident, this is a time that actually you go into a little bit of unknown, and you just need to put yourself, articulate things, even though you kind of a little bit kind of empty a little bit, but just pushing for. And those words, number of words are really the aim. Main game is to drag you out into that space. Okay? If I say I have no limitation at all, you probably write me a couple of paragraphs, and the rest of it is just in my imagination. So, so if you happen to like your name, then you might get more score, which is probably not a good idea. So that means that is just that intense, but it's not really set out to penalize. Okay, penalize you like, oh, I missed by 5 words, and you keep spending time trying to hit those marks. Don't worry about that too much, but just keep that some in mind. So I would say that from my experience, 2.5 page is relatively good. It's allow you to stretch yourself a little bit in terms of, because this is a lot of design thinking is really in this size of the words that you put out. It's not really in the technical work that you do. Okay. So just hopefully you get that. A lot of this is from the same thing. Okay. Similar things. So this is what I suspect. Everything submit through Milo. There's no paper-based, no nothing. So basically, the only two things. Report, the number 2 here, in PDF. Okay, submit that. And the submission on Milo here, you can feel free to submit anytime. Okay, so until the due date, you're allowed to submit multiple submissions. You don't have to email me or anything. I would just pick the last one. Yes, so just make sure the last one is the one that you want me to see. Otherwise, I wouldn't know which one you want to see. So that's why if you find that you make a mistake, just make sure you dump a new one in there. Okay? I always pick the latest one that you submit. Okay, so the first one here is a bit tricky. So this one, don't have to worry too much if you don't know what the bill is and things like that, because you're going to be working with us for the next couple of days before you submit this anyway. This is not until Wednesday night, so that means you're going to have us today and emails and over the weekends, and also a little bit up on Monday. You will see me, and Tuesday and Wednesday. So I mean, by that time you will know what that is. Okay. So essentially executable. It's a portable unit. It's a built version of it. So Oculus, you will send a folder of that one. It won't send the whole Unity project, but as you probably realize, actually your Unity project now is about 2.5 gigs, so you probably don't want to dump that on our server. So the build version will allow you just to see. Okay. But one thing that you have to be sure is that usually people don't pay attention to the build version. They think their project is working in Unity. They just build, they just submit. And when we open it, it doesn't work. So what you actually should really spare at least half an hour to make sure when you build it, you test it. You test your build that actually is run. Okay, it's run properly before you submit. Okay, and that's just a simple logic. Okay, so don't leave this at the very last second. Okay, try to spare half an hour. Testing is really simple because the build, the hard work already done by Unity. That's what the Unities do. Convert your unified codes into different build version. Depending on the platform. Like PC, Oculus will definitely go PC. Vuforia that you're going to learn today is based on the AR component. That can go both ways. Can work on the Windows platform, which is executable, which is run on the webcam, which it could be on your laptop or anything. Okay, but Vuforia is actually can also palm it into an Android component, iOS as well. But we don't touch in this unit. We don't touch iOS. It's not because we don't like iOS. It's because the process of getting to iOS device require a license. Android is a bit free, so you just have to make sure your phone is turned on, unlock the developer mode, and you can feel free to load up your software. So that means we are stick with Android only. Anyone, most of you will have Android, but we have 6 phones, so I mean that should be kind of getting yourself in the ballpark. Okay. And let's face it. You can even actually share a phone among your friends because they can just port that and see whether apps are working. Okay. Most of the time you work in Unity anyway. All right, so that means I think the note is just saying, okay, Vuforia, you have 2 choices. If you really don't want to deal with things with mobile, you just stick with a webcam, that's why. And all the computer in the lab has a webcam attached to it, and your personal computer will all have a webcam. They all should work. Okay. This one, second one is obvious. Okay, so when I say you develop technical work, it doesn't mean that you get somebody else and you just erase their name and then put your name on it. Okay, that would be obvious. That's why we could potentially ask for the source code if you don't cite people's work, and we realize that okay, well, you really do a significant work in the past 48 hours, and then so that when we could ask for that. Okay, make sure you cite them. Okay, cite reference and all the source code that you use. Hopefully that's clear enough. Okay, so report here, I have a suggestion on how you go about this. So this will align well with our, in terms of our marking in criteria. So this one will fit well. So front page here usually just so that it look like a report. Okay, so have name, ID, and everything. So that it doesn't look like everything is dressed up differently, 85 people. It just look kind of standard so we can see whether it's the right person. Screen capture of your application, so usually means a screen capture in Windows. There are plenty of in snip tool, snipping tools, things like that. You just snap your screen interface from your Unity development. You stuck it in your report. Okay. Don't have to make it too big. Yeah, so that's why I suggest something. So it's just like a report that has a little bit of picture attached to it. And this is really go addressing all the criteria that we're looking for. Okay, description application, so that's the first four points of the 20 points. Address what theme you fit, so at least you know where we're going, where you're heading. So it should generally is simple. And the interface context of your theme, this is a really require understanding, a little bit of why will you pick this application, why it's significant in themes. So this is really not about technical component at all. It's really understanding what's the significant role of that application inside the theme. Let's say you pick health, why you pick this application, why it's significant in there. Okay. And this is one that actually is a bit new for you, interaction design. So this is where hardware, software design is sitting. Okay. This is where you design what are interaction, why your interaction that you select is significant. Yeah. So it's, as I said yesterday, it's that no right or wrong per se, okay, but you depend on your justification. Okay. And the models here are really not strict. Okay, it's basically both import and create it. Yeah, some people might, as I said before, could create it, but this unit is perfectly fine. If you don't want to create anything, you just download. As long as you have contents, not an empty room, okay, has something that indicative of what you try to do. Okay, So that means most of the students will spend time looking in 3dwarehouse.com, looking for model that actually free, that actually allow you to kind of, project it inside your Unity. And import into Unity is extremely easy, drag and drop. Yeah, just find the right content, put them together. So this one is just, the reason I say that this is super easy is that some people might think, oh, I pay $5 to get a fancy content from the internet, and then you will get more score. When in fact, no, you won't. You will get the same score with people who get free stuff. So don't worry about that. I think the way to do this is that just try the content that fit what you need, and then that would do well, best for you. Okay. And of course, reference. This is where you cite a lot of technical component in there, and also cite some paper that you read. Why would you think you have a significant, why it's significant in this domain? So you might have a paper that talk about that. That would be ideal. But you don't necessarily have to that. You can look at, just like assignment 1, you have YouTube, you have everything. You can cite all those things. Okay. So hopefully it makes sense. Okay. So now let's move to criteria. All right, so criteria is make it simple. Okay, so when we mark, we simply looking at the top one. So this applications, whether you have details, the one that actually explain the significant very well, then you get in this ballpark. Okay, if it impress us a lot, then you might get full mark. If not, it's somewhere around 80%. Okay, but then if it's actually you pay attention to the highlight. Okay. Because this is all the same. The one here you explain, but okay, it's not that particularly well explained. So you learn about distinction. And then if you do this, and then I highlight this one, so like you document, but not very clearly. Yeah, you kind of write something. Usually what I found in the past is that they ran out of time, report is the last thing they do, so they just write a couple of sentences, and that's it. So that you will fall right into the, either pass or credit. But for those of you who are really concerned about failing, and you can just look at how you're going to land it and fail, or you have a wish to go into this zone, so that you just have to hit that one, is that you did not document anything, so you just turn in blank page or those kind of things, so you definitely land in that fail period. Okay, so not to say that that's what you'll be doing. Okay, so the second criteria here is interaction design. You can see here, start with the HD. Those who are looking for HD, the bold letter doesn't come out that well, so but you can try to see and try to bold the part that actually is significant. So document clearly the detailed descriptions of your proposed interactions. Okay, and your second is a I used to use the word quite strong academically, so but now it's a bit more layman term. Convincing. Okay, convincing argument. Okay, this is not convincing like not so convincing in my mind. It's like this application cool. Something like that, or this is excellent, this is going to do this. When in fact, convincing means realistic. Okay, even have more reference would be even good. Like, oh, these people are talking about these, that future could be in this, this technology could be the emerging of that. It's really realistic assessment of that would be the best argument that you could put instead of my application will solve the world hunger and will do all this big problem. By the way, I move avatar 2 centimeters. I mean, those are the kind of things that doesn't look fit. Okay, so convincing argument doesn't mean that you champion. It just means realistic, strong, realistic argument, and that will do. Right, and then, so this one, convincing, some people would have some argument there. If I read, they say, okay, yeah, you put something there, but it's not really convinced me somewhat, and so it's just kind of fall down to that. But it's probably not a concern too much. Yeah, so, and you can see the technical here, I definitely change quite a lot. So if you have things that working, no problem, then you move yourself into HD in that category, okay? So if you have some problem, okay, so when we mark this one, I won't be marked the technical and the model. Basically, Lindsay and Lachlan is going to be marking those. I mark the rest of it, okay. So that means if they open it up, doesn't work, then you fall all the way to the here. All right, so and then if you're actually barely working, that means it's somewhat like you're hoping that it's working and it's somewhat working, then you kind of fall somewhere here. Semi-working with a few programs, so that means most of the time it works, but it's clear obvious problem. Okay, so that's the kind of gray area a little bit, but the HD is very clear. Open up, working, running well is perfectly fine. Here you move that one. Okay, so in that case, the Lachlan and Lindsay wouldn't have to make gray judgment. They just go straight to it. Okay. Model is the same. You import, you create something very clear. Okay, so usually we'll just believe that's what you have in, and then I think they will cross check. They would cross check on the reference. If you have fancy word coming in, and then you suddenly don't reference anything at all, and then we'll do deeper, and then that's when we start to question whether actually this is, you mistyped the report or you misreported it or something like that. We just try to cover it. And some of the model here is without any problem. The second component here is really because sometimes you import it, and your model is actually either missing one phase. Sometimes you will see this when you import free stuff from internet. Some phase will missing, some things, all kind of weird problem. You will not get a chance to fix them easily. Okay, some of this is because then you're not building the model yourself, so you just grab them, port it in. So something wrong, they might suspect something, but you won't have time to fix them. You just go quickly move to another free model that you can try it on. Okay, so that is something there. So that means one is inside. Let's say you put a VR, Lindsay and Lachlan put in. They see the model. They look at your title. Oh, okay, this is look like what it can be. They won't be judging how you design them. Okay, they're just testing whether it actually works. Okay, yes. And remember the technical details that I think did I? Yes. In the report, you just make sure that actually your what interactions are there, because this is what they're going to be looking for. Okay, they'll be looking for that part. Okay, this is the 3 interactions, or maybe 1 or 2. Okay, and this is how I do it. This is how I move. Okay, they will just go in there, move. Where is it moving? Okay, that's it. Yeah. But then the model here is where the model is to do what it's supposed to do. Okay, if your project about forest, then okay, there's a tree, there's something. It makes sense. It doesn't have to be complete. So that means the criteria is very, very loose. Okay, so in the model size, it's very loose. So that's why it's anything indicative of what you think. So usually the just judgment of yourself, of students themselves, are actually good enough. We won't be marking like, the tree need to have this, need to have sun, this to have this. That's not what we're after. Okay, although you can't go into report forest, and then you put in a desk table or put in something that you find, the first thing you find or the last minute you can find, and then dump thing in there. Yeah, so, all right, so hopefully that makes sense. And report, it's as usual. This is a style report, okay? It's not about the whole report. It's about just the style report, the way you write, okay? Because the content, everything else is also your writing, okay? In the first top part, it's all writing, okay? Like this part I'll be marking. So out of 20, I'll be marked 12 of them. I'll be marked 12 of them. And the other 8 will be marked by the tutor. Mm-hmm. All right, any questions? Yes, sir. We try to finish marking by, for your assignment 1 due tonight, I try to finish this by Monday. Not before lecture, probably the night on Monday. But on the assignment 2, we try to finish that by the end of December 7, which is Friday. It's a bit our target, because if we miss that, it's either mean weekends marking, because otherwise the next Monday the regular tutorial will come, and we would love to have the feedback get to you somewhat before. Yeah. All right, so we'll try to do our best to keep up, and hopefully you can keep up with us. So any questions? Okay. All right, so let's move on to this one quickly. All right. Today is about interactions, okay? So that's why usually this one is more middle of the semester, but I roll this one up so that you're actually going to be important for you to get this in your head before you actually start to really seriously working on assignment 2, okay? So 3D interaction, that's particularly what we're after, okay? So you can see the pyramid that we have yesterday, okay? So the building block from the bottom built up, okay? So all the tools, so you know the components. First, this is a display, the different device, trackings, things like that, which most of these you don't deal with, and you just kind of use them, okay? So Unity, the tool, the Vuforia is an AR, which is run off Unity. That's also already available in Unity in your lab. And easily available in your laptop if you want to. Okay. And this is where you're actually going to be designing the interaction. Okay. Okay. This is again back again this is really the core. Okay. So we'll tell you different. This is, you just have to understand how to use it. You don't need to excel or advance any of these components because it's going to take more time. But this is just as good as your imagination, understanding of how the technology and married with the design. Okay, so this is important, and that will reflect in your report. Okay. So interaction tasks here, this is from the very old stage, okay, from 2D, which is most of you, we all use in our current computing, laptop, cell phones. Okay, so that one has selection, text entry. So this is a term that people use when they're doing research, but this nowadays is just kind of commodity. So you should use that as it's actually given. Okay. And then now we start to moving into what the 3D components, which is that what the wave of VR and AR bring, okay, bring into. So now actually all the interaction navigation, interaction inside that new interface paradigm has to be adapted. Okay, so that means that people now start to looking how to actually navigate inside VR. Right now you're actually being told how to use the joystick, how to use that, how to use this. But if you think about it, the people who design this, it's actually you have to design how you actually want to move inside VR. For example, the one that you used yesterday is the default scenes, teleport. That one is actually, it's a technical driven, but if you look in the code, actually they have paid some attention to the fact that how can you move from one point to another point, and then in that program you allow you to actually fixate the new viewpoint. So that means you do not just go straight and your head not move. So you can see as you move to a different teleport, your head movement is changing. Okay, so those are giving some thought. What actually, and usually that means is that if you move to the wall, you don't want to be teleported next to the door and your face is straight into the wall. So that's what is actually you're thinking that, okay, your interaction design would have to change that angle a little bit. If you look into the source code, you will see they're manipulating change. So if you move closer to the wall, your head rotation will go somewhere more visible. Okay. So that's the navigation. Okay. So there's quite a number of them. So there's a book by Bowens some years ago, I think, but that's still a landmark for a lot of things that you can read. I think library have some of these books, so you can have a look there. Selection. Okay, this is where actually it hasn't evolved much in the last 20 years. You can see here all the joys, the Oculus Touch, the hand controller. They actually look nice and everything look cool. You have virtual hand, but essentially that's the same thing that we have, that we always have. So it's basically it's an obvious one. But you see that the fall for that one is that you have many buttons. Yeah, maybe some of the project is how to actually create this control or selection that actually more intuitive. Okay, they already introduced something here, but I think you can think about those. Those could be a particularly just one niche project you can do. Okay, how would you actually teach people? Are you going to ask them to learn about its 10 button for half an hour and go and play, or do you actually have something inside your VR system to help them? Those is actually part of this design component people do. And manipulation, you will play with the hand control, grab things like that. The Oculus take a step that actually take the fact that if you have a virtual hand, you're looking at a deductive approach, so that whatever you not touch, they interpret as the presence of the hands. Okay, so it's like you will see your hand going out like this, but in fact there's no sensor, right? So it's practically just detect that you're not touching. That's what they call touch. So basically it detect that you're not touching, so therefore your hand must be here. But whether your hand is here or there, it can't tell. Okay, so your finger is either here or it's point like that. Yeah, so that is a kind of thing that you kind of look at. But for Oculus, that's worked well for them. Okay, I think that's one of the nice things that actually they work well compared to the other competitor in the Vive system. Vive system, the controller done certain part better, but in terms of hand control, look less natural. Okay, so and they're much bigger too. And system control, data input, this is not easy task for VR. And to input is that you have a keyboard, and what you're going to do, you're going to go and doing this keyboard. Yeah, so that's why this is not solving directly with the visual and tactile control. It's not simple. Wearable computing used to have this small specialized keyboard that you kind of go around like this. Okay, but that is actually try to fit what they can have inside what they need at that time. System control, data control now, I think it requires much more technology. This, I think, it really much go in AI phase, in voice recognitions, those kind of things, talking to the system. There's no point for you to be able to type in the real world and then go and do the same task inside the VR or AR. Yes, it's just a technical change, but this actually doesn't really pay off that well. Yes, so I would say that the technology would go into the voice and those kind of things. Mm-hmm. Yes. So, but this is more or less when Professor Bowen from Virginia Tech, so he introduced this. He wrote a book with his colleagues, so to compile all this different work, okay. But then the AR came along in the late 90s, pushing through. The problem for the AR or the new technology interface that they don't know how to interact with this medium. So what their approach is using is that they just use what people are using for. AR is the same community, basically the same lab with VR lab. So you will see that a lot of people do VR, and the colleague next one could be do AR, because essentially they're in the kind of same cycle. The two top conferences in the world, technical conference now is in VR, is IEEE VR, okay, hosted annually. The other one around the world, so they change country host. And then the other one, ISMA. Okay, ISMA is an international symposium of augmented and mixed reality. Okay, both of them actually, in AR conference, actually there's a big section about VR. In VR conference, there's a big section in AR. So that means you can tell that these people are, oftentimes kind of jump around, okay? So what that means is that it's essentially they're tied together by the hip. They just happen to different focus, okay? And then some of the technology are similar. Like right now the tracking is not, but the phone tracking and the Microsoft mixed reality headset, when you have require no sensor, they are practically the same thing. All right, so this is a typical interface design path. Okay, so the top line here, developments of formal theoretical models. Okay, so this one is really system that we know well. Okay, so this is a predicting how people are going to use. This is really for a system that actually has been out about and then had been around for many years, so people have studied them comprehensively. Okay, so this is, for example, like a desktop, a window, mouse, pointer, so everything you use nowadays. Okay, the theory, the famous kind of well-known theory in that space is like how to be able to predict how fast you're going to move from one point to the other point on the screen. Even though it's meaningless for us, but that is actually as good as how they understand it. They practically understand that. But it's a very simple equation. Okay, it's a function of two things: the distance you move and the size of the target you try to hit. So what does it mean is that it drives the interface of the 2D graphical user interface. The bigger the screen, so that determines the size. So what that means is that the longer you have, basically the size of this has to be proportionally. So otherwise you end up travel far distance to hit a smaller target. It's just like you're shooting a star in the middle of the galaxy, so the chance of hitting them is very little. So what that means, it will cause the user to go very slow. So essentially reduce their effectiveness. So that's its kind of modeling theories that they're digging into. So now, if you move along a little bit, then you have the interface. So this is like not less mature, okay, but somewhat halfway mature. So this is like a development interface. They actually know what they're doing now. So this is what usually that in this space. So VR is now a little bit in that space. Okay, been around, few waves of up and down. Now actually been sustained. So now people start to kind of know. Next week I will talk about one of my current projects I do with the field that usually don't use VR at all. That actually people now start to realize what VR could do for them, not just because they need to have millions of dollars like airplane or big industry. Okay, so this pump is actually just basically more conventional business they can start to use. So this is where a lot of interface really know how to go about that. And then, of course, when you start to come out, this is, and you can suspect that this one start to come out with interactions techniques, so you don't really know what best in your new medium. Like AR came out, like what exactly is the VR different than VR? So that I think that people start to question. So that is when you actually start to borrow. We use the word adoption. Okay, so that's the same thing. You follow, and then you have these things kind of available for you. So you will see a lot of what I will talk about now, this center around this interaction. Okay. So in this case here, I think in this image you showed you yesterday, so this is a more typical 3D annotation, okay? So people in the world, okay, so this is annotation of space, okay? So in this case happen to be this is pig skin for surgery simulation, emulation itself. So you can see a little bit on that, what they actually see, okay? And you have something like this, context-based information browser. Okay, so this is more context-based mean it's kind of precursor to the augmented reality in some sense. But a lot of people kind of get lost because the pushing in AR was so high. People not realize actually having things floating in midair is not necessarily the end. It's an achievement point for AR. It got to be that relevant to the space that is actually projected to. For example, you want to project something, it should be relevant to wherever you stand here. Okay? But even though when people observe or experience AR for the first time, they don't really care. Like you put on HoloLens, you see things floating, oh, that's cool. Yes. But the thing is that you can apply that to anything, or you have a data and you want to talk with colleagues, and you sit in the middle of a meeting room and the whole thing pop up. Yeah, it looks like a prototype, look like AR prototype. But this is the kind of concept that actually they didn't really pay attention to. If they have that visualization of those contents is fine, okay? But what is actually not fine is that how you would take further from that point, okay? So that's why AR was a bit tricky to make it work, okay? In VR environments, by the design, it's much simpler because then you control the whole environment. It doesn't matter where you're standing. Once you put VR on, you're practically inside VR world, just like in the lab. It doesn't matter where you have it. You put on, that's become new world. So you can have a clean slate. You can build anything, surround it, everything. But in AR, you still see the real world. And how to make your content relevant to real world, how much you want to make it's relevant to the real world, that entirely have to work into a sweet spot. And that's what killer apps is good for. That's what killer app need to hit that spot. Pokemon Go used to be that for about 4 months, so until people realized actually, yeah, it could get a car hit them, an accident, or no longer have the drive to do that. So this one is actually a work that by Professor I think his first name is can slip my mind a little bit, but he's actually from University of Tokyo. Okay, so he did this work many years ago, but it's about context aware. So he will hold this mobile handheld device. They're looking at a simple barcode, which is you can see in the middle there. And basic information will come up. Like, for example, this will tell, oh, this is about this section, what they are. Okay, so that is what the context aware is. That they're standing right there. That's what they were looking at. Okay, so similar thing here. So this work is also the library part, but this one would show you what the duct tape people look like. So there's a lot of marker there, so they come from a similar library. Okay, so this is where they stage their problem. Okay, 650 and everything, catalogs and things. Okay, and this is their mobile unit. Okay, so you can see here, he's a very strong man. So because that thing I don't think is light. Yes, sir. But this is a clever way, okay? So this is like your smartwatch, except it's 15 years earlier, okay? And you can see his virtual keyboard there. That's his augmented components tied to his thing, so his hand can be moved like that. But one thing you would notice that his thing has a lot of latency, okay? So what that means is that his hand moves, the whole thing kind of drip around. Okay, so that is the yellow one here is a good way. It's a navigation part. Okay, let's say you want to put the books in here. This is similar to the books example before yesterday. So this is guy, you want to see this book. Okay, there's another example from here. So this one is like instead of you go to the kiosk, you actually search it from there. Okay, it's really not. Well, you think about it. Well, the form factor is really not going to go anywhere. But what happens if this thing is actually available on your cell phone? Yeah, so. And that is a clone version of what you see on his head mount display. And you can see all the marker around his shelf, okay, and all the books. So, but with the current technology now, all these markers are not necessary. The Vuforia allows you to train, so you can get the digital image of the book, or the cover of the book, and train that as a part of the marker. You can do that now. Actually, you will do that this afternoon. And you will notice one thing, that most of the work, early work, is that they're running probably no more than 10 frames per second. Okay, so what they get around, if they move normal speed, they will see like that. Okay, so I think this is already slowed down version of how he moves. So I mean, it's just so that it actually doesn't really get, misregistration doesn't get that bad. But you can see here the interface is a little bit interesting. Okay, AR could be that. So basically, essentially, extension of what your physical object will look like. What happens if your glass actually can extend what you can see on the watch? I mean, those are kind of concepts you can look back. Oh, this is a navigation thing. This is a 3D. How would you actually show the 3D? So basically, it has a little navigation wayfinder that actually have a little bit of a three-dimensional structure to it. So you look like you're looking inside the tube. You see, his trick is pushing every marker everywhere. So, but that's what I think the research is at that time. So this one is, you can see here, AR, wearable computing, AR simulation. This is really coming live nowadays. Okay, so all of this is really coming through. So I mean, a lot of researchers went on to be the backbone of this industry. Okay, so however, this part, that really about annotation, is a bit hard to interact. Okay, you need a special device, so things are floating. It's not that particularly easy. Even though now new technology like hand gestures and everything is more mature, more widely accessible, so now you actually get better chance of interacting with more naturally. Okay. So second one here is actually, this is what we call ideal. Okay, in 3D interaction. Okay, so this is actually when you actually two people wear a full headset. Okay, they go about interacting inside the space. This is also what we are achieving now with a multiple HoloLens device. Okay, so that's see, because the HoloLens is actually projecting stereoscopic, so you can see a holographic floating. Okay, you got to see that next week. Okay, and then a couple of them can see the same thing, but you, of course, you need required to make them work together. Okay, usually mean network linking, anchors, and things like that. So to make the two devices looking, knowing each other. Okay, knowing where each other looks. Okay, so that's quite a few. Okay, this is a big effort by Japanese group in the turn of the century that actually looking at try to make this whether they can play a game. So that's what a lot of Japanese do, is that basically they pitch into the game side. So in this case, it's like Alien. The A come out, you know, the movie Aliens, and then basically they are supposed to be the soldier, and this is the image in which they see each other. That's their real life. They look like that. The image on the left. But then when your team, which is about 4 of them in here, they see them, they see them in this kind of suit. Okay, I think this one will start to show up in the studio in the U.S. Okay, not like this set, but it's actually a actual full-on in-suit gaming. Okay, I think that is actually not that far off. Okay, so but that's the kind of idea. Okay, but it still highlight. You can see the disadvantage. They still highlight very clearly. HMD is a key. It's a little bit problematic for them. Okay, because that all this trick is go to the HMD. How they do this is a similar way of how we're doing now. It's actually we recognize where the other object, the person are, and we track that person. We track myself. So if I move, my colleague will know how I move, and they will project the augmented contents onto my face. Okay, so they appear like I'm wearing some kind of virtual helmet. Okay, the same concept here still works. Okay, HMD, the projector disadvantage, nowadays still at disadvantage. Okay, even though it's advanced in the technology, the design principle is still limitation. Okay, so nobody want to wear this kind of headset, even not even military. Okay, only certain ways. So that's what I think a lot of big companies now learn from Google Glass. Google Glass is actually overcompensate. Okay, they will go for form factor that actually no one complain about wearing Google Glass because it's just probably lighter than your glass. However, they trade off a lot of things. They trade off a lot of things. Their power, they no longer become self-sustained, have no tracking capacity. It's simply just a small micro display. All right, so maybe I'll take a 10 minutes break. Okay, I'll be back. Let's get back here in 10 minutes, 10 past 10. my trip to All right, so resume. So now we're talking about annotations. Okay, so the next thing is that we're looking at something that actually you won't get much chance to look at it inside the tutorial, but it's actually a very important class. Okay, it's our surface and a tangible interface. Okay, that's what we talk a little bit slightly in unit outline about the tracking, ability to track. So this one image does not look quite good, but essentially there's a projector there and there's a camera. As I said, use example of the coffee cup before. To be able to superimpose that on top of it, you practically need to detect where the cup is. And the way to detect now is most of the time commonly using camera. Okay, you will see some at international airport that that's projector and then you use for attraction for students. They will go into try to step on a virtual projected fish or some object, something like that, or kick a ball, and the ball will interact with the way the student move, or it could be anyone. It doesn't have to be student, but the student is the one that engage with it. So that's a similar thing with that. So that means this is really designed for helping hands. People are projecting where they are, and then they write accordingly. They give them some help. Okay, so. For example, this one, now I remember him, so he's Professor Jun from Sony Hill with the University of Tokyo. Yeah, what happened? Yeah, the sound doesn't anything significant, yes. And it's also in Japanese, so. Oh, it doesn't scale up that good. Yeah. So you see the projection, okay? Use the mouse control, and the table also project, okay? And you can move the content into here. So this is quite a little bit of something that I think is believable, okay? Even though this is quite almost 20 years ago. We work on multiple cloth surface. Of course, this is really just a prototype, okay? We say prototype. And you can see here, the interface here is really designed to deal with multiple surface, multiple kind of mediums, so you move things without boundary in some sense. Technically, at that time, it was really challenging to get this right, okay? So this is actually project further into our collaborative work between different people looking at a big table together. And you have a big projection, so you're talking about slide here, going here, so I could, similar thing that I do here, but actually the more interactive, I can put a cursor, move things around, okay. So a lot of sophisticated technical back-end to make this work. But you can see the concept here, the design level, which you should be able to see. I want you all to see that actually the way they designed it, so this overcome this multiple surface, create a fully functional collaborative component that your people could put content in a screen. You can grab it on screens, things like that. But nowadays you have this add drops and those kind of things, that kind of NFC, the near field communications, or these kind of things that kind of make similar function. Okay, you can exchange business card by just tapping the phone together. But this is kind of way out there when they're projected, which it actually is still very much very futuristic, even though now it's been almost 20 years on. Okay. Imagine if you actually start to be able to point using your phone to interact with the contents, allow the engaging. So one of the problems in education is that how you want to turn your students that come to class that pay attention to you. It's not just training a teacher, but it's also maybe giving them different medium to interact with contents. Okay. So this is a projection. There's a laser. They controlled it. Okay. And this is an interesting one. Okay. This is putting a virtual physical camera in there. This being the marker in there just allow the projector camera up front to be able to scan them in, just like a barcode. Okay. And then the barcode is work in three-dimensional, so I mean if they rotate, they know precisely. And that's what the very last one, I'm not sure you get it. It's basically taking the virtual model based on the physical camera that it just put it in and then display it out. So that's the kind of if you remember looking at a diagram between reality, virtual reality, and somewhere in the middle, this is a very quite a good exemplary project for that. And you can see here things are moving seamlessly in both sides. Some in virtual, and suddenly the virtual go inside of the real world and make things forward. So I think he's one of the foresight people. I think he's one of the true researchers in the field. Okay. So TUIs, this is not in Jun's domain, but this is more on the other side. MIT is leading a lot of work in this, but this concept is really simple. It's almost like a playwright, artist-like. Okay, so a TU tangible interface is born out of the fact that actually what happens if you actually want to engage with the computer or some kind of interacting beyond the point that you actually only need to see what you see, how well you will be able to grab. Even though the prime example would be the mouse, okay, the mouse that you use, the keyboard that you use, those are traditional, very first generation TUI. But this one go beyond that. So for example, you could have some object that not necessarily require you to do anything. Okay, like this is reflecting on the temperature in the lab that apparently have a very hot summer. So basically this is like environmental monitor system that actually allow, or not monitors, it's displaying. So the faster this thing spin, reflecting how much electricity they use. So this is a kind of campaign to consciously try to tell people that turn off the light, do this, and with this, instead of you just put a sign, say turn off the light, which you usually would do, this was sort of other thing to interact with it. And this is really try to get the message to them. Okay, like, so for example, have you been to, it's a Mexican restaurant called Zumba, something, they have a sign in front, they're actually more on entrepreneur side, that actually say how many sandwich, how many taco they sell, and then the target is to donate, match the funding to donate. So basically they have this for all the store. So when people are seeing it, they contribute to this. And then even though they're still thinking about what to order, that number will keep moving because the rest of the world is actually shipping in. So that's something that kind of interface. This is a good example, not to projecting that interface is about button to push, thing to do proactively. This could be reactively. You could perceive it and then basically get to the point. So this would be a good one to go as well. Yeah, that one is also a very good idea. It's of a live-wise talking about, it could be reflective or anything, because the way is that, well, you can't really see the red thing here. It's a little bit of a piece of cloth that here moving, okay? There's a wind that creates them. So the way they move reflects certain environmental index that they try to suggest. So that is about, did you decide that right? It just looked like a children thing, right? Just look like something that doesn't have meaning. But that's the beauty of the design. Whether actually you make these people to think that this has some meaning to them. Okay, so this could be value in a real world. Okay, beyond the push button and stuff like that. Okay. So for this part is that there's a physical object that you can design into. Okay, not just the whole field. There's a industrial design part of some architecture school. That's just all about this, making things that people design cup, like IKEA, everything's about that. So this one is actually what we take out from this is that there's a physical presence of object. So a physical presence here, how would you make physical presence work for your interface? It's not just the same thing with the mouse example. There's a many shape that you have, right? The many odd shape that you have. That's actually a lot of design going in. Certain part of the mouse, different specialized mouse, the game mouse. Anyone play big games? So you will see a game mouse that actually it look much bigger than normal mouse. It look many buttons, and those kind of things. So, but the idea of this is when we come here, it's called affordance. Okay, affordance inside the interface here is very important. Okay, it's basically the idea, the concept that we get it up from the actual design. Industrial design. Affordance is the ability for you to see when you perceive the physical object, any object at all, how much you can actually perceive the right purpose of that object. If you have the object that was designed with high affordance, when you see it, you can perceive the true focus or the true purpose of that device easier. So that means what that means is that you just see, don't need to read much, you already sort of get a half idea of what that is supposed to do. For example, this object. You have to guess here what it's going to be. Yes. So that's how affordance tell. If you think that is something else besides coffee cup, then that means it's a little bit odd. If the interface is actually, that's a dangerous thing to do. Because the interface here is about improving efficiency of how you work. But if the thing is actually take more time, even more time to learn how to use them, essentially it doesn't really it's counterproductive. So therefore, that affordance becomes the subjective quality that actually we all want to achieve that. If the button makes sense, that's why Oculus are putting a lot of effort into those. I think it's pay off in the touch, which is you look at a virtual hand. The competitor doesn't have them. But that is a differentiation point between them. That's allowed them to get the affordance. Oh, that's my hand, even though it's really not your hand. Yeah, so, but that gives you can see if you move your hands inside, it's reflective. It imitates how you move. Right, so I think that's quite powerful. That's it actually play around this idea of affordance. Okay, it'd be good for you to kind of get familiar with some of those. Mm-hmm. So this is all of this is playing around with affordance. Okay, if your affordance can play it right, so you can get this to help with collaboration. You can help this with increased understanding of the whole setup, because the interface is about getting people understanding. The further beyond this part, pushing further in psychology, is called cognitive load. Okay. Cognitive load is when you have a lot of things to do and you try to process that the most efficient way. Okay. So this is evolved beyond technical work, but not even design. Okay. It's just about human factor component. Okay. So this is a really important one. Okay. Limitation, though, in the physical object interface, it's actually difficult to change them. For example, whatever we build, we can't easily change the shape of it. Unlike the program you build on your desktop or mobile phone, you can change how it looks or how it functions within a matter of days. A physical object, could be entirely replacing the whole thing. Okay? So that is an inherently limitation that comes with a physical object. Therefore, when you have a physical object or design something that has a cost to it, it needs to make sure that it's actually pay off. Otherwise, we just do it because you can, which is a lot of prototypes that look like that. you do it. That's why the design right is actually one of the very key of trying to get this thing to take off the ideas. Okay? Because at the end of the day, people will ask, is it worth it to do it? Okay? Why would you want to walk in VR when you can just walk in the real world? Yeah, something like that. It's a basic questions. Okay. All right. So the next one here is really guide to. Do you remember the AR, the one that interact inside 3D, and then you have tangible component, and this is where Professor Mark Billinghurst made his name for. It's introduced new class, tangible AR. Okay. Which is a mix between them. Okay, tangible AR means you still augment it, but you actually can touch them. Okay, similar to the library example that I have before, the one you touch on the panel, search for books. Okay, that's to give you a bit of a tactile component. But this is actually go a bit further. Okay, the way it does is that the camera in front of her, in front of the ladies, are actually looking at this pattern. Okay, which is a marker, and basically can calculate the position. But the position here, this is a neat thing about the solution is that it doesn't have to look for where it is in space. It's only look for relative position between the camera that attached to the head and the marker. We call it marker, so it's just marker there. So to be able to superimpose that virtual character on the sides. So when you rotate the plate, the whole character move along with it. Okay. So this is actually a simple and very clever way of applying. It makes the problem simpler. Okay. Before this thing came along in 1998, AR system a big build based on the back of VR. So the whole room is actually mounted with sensor for you to actually be able to be able to track you inside space. So a bunch of these would be sensor. People build all kind of clever engineering, high-tech tracking device. Okay, with accuracy and those things. Mine included. I also built some of those. But this is actually a way to actually simplify all those. So all you have to do is webcam. And that's what Vuforia is taking that legacy forward. Okay. Okay, which is essentially all you have to do is webcams, which is now with mobile phone, it's coming online. What that means is that now you don't even need a web phone, you just need a phone. Yes. So with the phone has a camera. Okay. So that means when you apply together, so there's a lot of things you don't have to do. You don't need to care whether you actually where you are situated inside the real world. Because what you're interacting with is just about that card. So what you actually have to looking for is where the camera that represent her viewpoint that actually attached to the head mount display and the plate and the marker piece. And that's it. She can be flying, sleeping like this or on the side. It doesn't really matter. Okay, so instead of have to do full-blown tracking inside real-world environment, you just simplify the problem. The payoff is huge because that would mean this is the one that allows computer science to branch it out in this space. Okay, so, and this gives rise to eventually competitors called Vuforia, which we'll be using, and that's further along give rise to what also we're going to be, hopefully some of you will get to call AR Core, which is in the Google Camps, okay, which is require no marker at all. Mm-hmm. Yeah. Not even have to know the trend. Vuforia would actually still use marker, but don't have to have this rigid thing. They can train any image like you could try today in the tutorial. You can upload your image of your face to be part of the marker. You upload to the cloud Vuforia. You train, it sends you a code to put it inside your Unity code, and then they can recognize your image of your face and put some virtual object on it, next to it, anywhere you want. Okay. And AR Core is actually take further. You don't even actually have to have your face image or any image at all. You just simply track. Okay, so we'll get to that. Hopefully we get to the AR Core by today, but I think most of you will probably spend a bit more time in Vuforia. Anyone play with Vuforia library before? Yeah, so they would take a bit of time. So yes, yeah, all right. So this is a kind of lesson that people will start to looking at. I think some of what you're actually doing here is that in AR is going to be really important, something that you can interact in the real world, not just inside the virtual space. So this is some of the principle, okay, that I think is going to be useful when you try to write the design component. You can stick to some of these things, or whether some of these visuals is actually helping you. Physical controller for moving virtual contents. Okay, so in this case, it generates a sense of realistic attachment to the contents. You look like you wave in the midair and do nothing. And then the support for spatial 3D interaction. Okay, so this one is allow you to, just like AR was supposed to do, is move inside 3D. Time and space multiplex, we talked about this one before. This is related to task efficiency. Okay. Multiple hand interactions, so that's what when you move to headset mode, then your hand can still working, okay, which is somewhat going mobile now, considered advanced, but in terms of interactions, you get rid of one hand. So you only have one hand moving around, because one hand you have the whole of this. So it's a kind of trade-off between something that you put in your head and something that you hold in your hand, because essentially you hold one hand, you only have one hand left to do things. Affordance, okay, so the third one from the bottom, match affordance to task requirement. As I said before, high affordance means you understand the purpose of the device a little bit more even before you interact with it. It almost is a speak back to you, the object itself. So that means you just need to make sure affordance of the object, let's say you pick a mouse or this one is supposed to do something, then it should, the purpose in which you design should be, has a matching between what it looks like. Like this thing shouldn't look like, I don't know, what do you think it's not supposed to look like? Yeah? Yeah, so this is kind of thing that you would, it's kind of back and forth between, okay, this is what you want to design, this is what the object will look like, and then basically you try to merge between them to find the right match. Okay, so this is a very difficult one. This is what you should learn from Apple. Okay, Apple is actually do this part very well. Yes, that's why but people copy them all the time. So that's why I think they spend a lot of time in this industrial design component, which is actually how to make the app useful and want to be used or something like that. So you feel a little bit more of it, but of course they just not last very long if you most people copy them. So this is a basic classical example of what the task look like. Okay, you talk about time multiplex and you talk about space multiplex. Okay, this is just a classical stereotype. Time multiplex here means one device with multiple functions, but you have to do one at a time. So that's like a mouse. Okay, so mouse you can only do one thing at a time, move here, things like that. So it's just time multiplex. So multiplex means you just sequence 2 times. Okay. Space multiplex here means you actually have them in multiple places, like a toolbox. You can use multiple tools at one time. You can do a plier, you can do this. Yeah, so that's it. You can also see this. And so what is kind of task that you require people to do. Okay. Time multiplex have the advantage in terms of the equipment. Okay. You only need one device and they can multiple purpose. The trade-off is that you do need a bit of learning. Okay. In trade-off, let's say you want to do a certain thing that actually is along the line of sequence, you have to go through the step before you get there. Okay, so like if this is function is layer number 5, you go 1, 2, 3, 4, 5. Okay, but this one, if you want to do number 5, you might actually grab them and perform them right away. Okay, like for example, if the equipment has multiple functions, you can touch here, instead of one device, they do them all. Okay, so this is really just about design detail when you get down to the actual components of the actual interaction itself. Okay, so some of these just highlight what the spatial look like. Okay, so this would try to create this one space multiplex as a collaborative space. So you can see that's how he see it in the bottom left. Okay. So this is supposed to be different type of meters measurement. Well, that's a sound effect produced by computer science. So now this is what's going to happen. So translate it. So it's a simple trick. So you detect where the 2 markers closer together, and using your script to move the object between the space. It does have meaning, but it just doesn't look realistic yet. But essentially here, they were trying to see whether this can collaborate. This is just one person. Shortly, it will be another person walking in. And remember, everything now is attached to the real world, attached to the real context. For example, this one is actually sit on top or attached to the whiteboard, which you can write on it. And notice the interaction, the design here. Snap, grab something, object. Those are actually by they're designed that way. So you can see here, instead you can easily go to a toggle switch or click keyboard and selection drop-down box. You actually use physical movements of this multiple device. Okay. There's a research looking at area whether how if this thing is good for cognitive load, and that's going to be one area that is spin off. And that's to highlight the fact that that actually inside the physical space. So now you can get a mixed component together. Of course, there was a limitation that come with it. If you start to move all those markers, what happened to your writing? Looks like your AI is working, but not at the right time. Okay, so this is when the second person come in. This is where the researcher, this group, they try to project, oh, okay, this technique could be useful cognitive. Okay, the work here, I can tell you, doesn't have psychologists involved, so it looks a little bit like a prototype. Okay, but you can still kind of see. Okay, it's probably useful for you to kind of see this so that you can actually look at when you develop things, the kind of thing that you do. You might not feel good about what you're proposing, but actually you look at this. This is a full-time researcher. It's not look good either. So that means the idea is okay. I mean, as far as the idea is tried through in your design report. There's plenty of flaw in here. Okay, if you detect them, you can write about that too. Ideally, he would actually be collaborative. What do you think is missing in this picture?
Modern technology.
Yeah, that one thing. But in terms of interaction design.
He has to constantly look at the monitor.
Yeah, that's correct. So the metaphor here is a little bit broken. It's not complete. So the idea here is that if they design a space to be looking at a board, why he keep turning towards the monitor, which is actually, that's what a backward. But I think it's just a convenient for them to do this. But essentially here, this is where little thing that when you look at this over is useful to be picking those things out. Okay. Yeah, so this is a kind of basic dictionary that I have. Okay, so if these two cards go together, what that means. Okay, so the idea for this one is that you can flip-flop and change whatever associated with the physical space very easily. Okay. So that means it's quite interesting that they were looking at that area. Okay, and the code is simply detecting proximity of the two cards because you now have the ability to track them. Okay. Next one is actually interesting. Okay, this one is actually time multiplex. Okay, the other one you can see here multiple pieces that they can move them, everything around, so they can use multiple people can use them. It's good for collaborative. And this one is actually time multiplex, when in fact one device would do one thing, one device would do one thing at that time, at one time. Okay, so this one is supposed to be. This is done by Japanese researcher. Okay, it's Dr. Kato-san group. Okay, yeah, so technically it's quite cute. Okay, so. Given the technology they have then, I think this is not too bad. And the sound is actually give, as ours is my sound, it's actually give them a sense of the furniture has a little bit of squishy feel, make the wood. And you can see here, if you look from interaction standpoint, it's just single device, and you keep doing it, okay? But what's the purpose of this? As I said before, this is early work, so therefore the purpose is weak. Okay, this is perfectly to say, okay, instead of you have catalog in 2D, you have a 3D catalog that actually you can manipulate them. But nowadays with IKEA apps, the other person mentioned the other day, IKEA apps, I mean, that kind of thing, you can put the furniture right in your living room. Yeah. But this would be actually excellent children too, children games now, like a dollhouse or something like that. Yeah. But this is the kind of concept try to showcase what the time multiplex look like. There's no clear answer. The time multiplex, spatial multiplex is which one is better. It really depends on how you apply them. Okay, what the requirement from the task itself. I think one thing that I did very well is squishy sound. I think it gives them a sense of that this has a stiffness, but in fact you have no other sense of feedback, that actually this thing is a real object. It just looks like some polygon that you're pushing, but the sound make a difference. All right, so this one is one thing, and then the other one. Okay, this one is actually born. I helped setting up at a SIGGRAPH conference many years ago. This is AR graph. Okay, so this one is about music. So this one is same marker here, and you can see they spin the heck out of this technology many years ago. So they have a kind of DJ disc when people will keep moving the disc, play music. But in this case, it's actually based on the distance of this thing move. Okay, and then this one does have music. Okay, probably help. And they can have this at the expo. There's quite a few people come in. They are practically just a type of DJ type. Okay. The camera is on the top. Okay, and that's what the scene works. Okay. Pay attention to the tune, the frequency of the sound changing. It's based on how they move. So it's just like a DJ, but it's in an augmented world here. Except that she doesn't much look like DJ. She just keeps moving around. But in fact, you can see this is an actual live, actual real audience. You can see they have tattoo, everything, so they look pretty much like someone that kind of in the music thing. This is from the camera view. Okay, since you have ability to track them all the time in a 6-degree freedom, you can tell how road oriented they are, and that's it. When people spin this, they not just tell, oh, you can rotate things around. When in fact, this application about design that to match with the audio. Okay, this hand is actually they use the rotation and the distance to actually manipulate the frequency of the sound. So that means they will move around, just like DJs are moving the disc and things play sound. And this is creating a quite an interesting, engaging tool. So I mean that you have two of this marker in the scene, and they keep moving, and then there are two of them interacting, and the sound mix between the two of them. That's become quite a good show at that time. And you can see here, the underlying technology exactly the same with what Mark Billinghurst introduced. Okay, so it's just a spin in different application. This is perfectly fine. If you want to do this for projects and things like that, do somewhat of the music, and this is just kind of give you some idea. Okay. Now, just to recap it, so this is a tangible AR, so there's some clear advantage for that. Okay, so you have create a reconnecting between physical object and a virtual object, which is what VR was kind of severe cutting off for that. So you have this somewhat of a getting back. So now and they have spatial interactions with virtual objects. So in this case, a virtual object always attached to some markers, so you feel like you are touching physical virtual objects. So that's somewhat of a view as a strength. Okay, advantage might not be the perfect technical word for it, because it doesn't mean that it's actually you have this, it's always going to be good. It might not be something that you need. Okay. So, but definitely with this kind of technique, sometimes it can be difficult. You have a HMD, you have required headset, sometimes projector. It's not very. Essentially, the whole thing was the people moving, but all they're looking for is a screen. What the screen look like? When in fact they should be looking at the disc. Yes. So that's why HMD required. Sometimes could be a hassle there. But this is a kind of a fundamental hardware level kind of design. When the limitation, okay, so that's why when you move past this one, you just have to understand when you write weakness, strengths, and things like that. So some of these is perfectly fine, perfectly legitimate point to talk about. Okay, so don't talk about too subjective. Try to cling on to some point that actually meaningful. Okay. This one is talk about metaphor. Anyone heard of the term metaphor before? Yep. It's differently.
Yes.
Oh yeah. So in our case here, in the interface design, in this context of this unit here, metaphor is really just a way you're projecting your design. Okay, sometimes it's hard to say, oh, my design look like this. You move this, this will happen, this will do this. You simply tell them, my interface design is like this. It's like a magic lens. You kind of move your hand inside the vertex, inside space. And in this case, it's the same thing here. You want to scan, and basically you have the box that kind of run through them, and then you have an X-ray. Basically, just display the part that you're moving to. The box here is supposed to be moved past in and out, just like you cut them in a cross section. You can just move them out in and out. Okay. So that's useful to handle them. For example, like this, you call AR lens. You might say, oh, okay, what that means? Yeah. So that is a neat way to look at it. Okay, so that's the one PhD out of this project. And this one is, instead of just look and have something there, and then now you have two sides, you can stretch them, bend them, so it's like a film, a really thin film that actually have augmented layer on top of it. When in fact, there's nothing in there, it's just a two controller. Except that it actually have to create an interaction that actually recognize all these four corners of this film. Okay, so then stretch it out, things like that. So it's those that kind of give you some idea what it might be. Mm-hmm. So this one is a terrain model. Okay. Yeah, I think it's interesting. I think now some of these ideas will get to be revisited. Okay, it's with the new recent technology. So, so that just gives you some idea of what. This one already started. So this is the other one that actually interaction that's quite interesting. I think this is what Oculus Touch is actually not borrow, but it's kind of similar in principle, but not technical. Okay, so this is what we call occlusion based. Okay, so instead of you look at what you touch, you actually look at what you're not actually touching. Okay, what you actually occluded. For example, this one, you can see here, the marker here, you try to mark out the area in which she was doing, so that actually you allow yourself to actually have your hands, because one of the problems with AR before, and still is that most of the device doesn't have a depth sensor, so you can't detect the foreground easily. Okay, you can do that, but it's a lot of power, processing power to do that. So you end up having a virtual object kind of superimposed on your physical one. The way to do this is actually, if you have the marker, just in this case, it's just blended underneath, they're just looking for how the hands is occluded. So what that means is that they just manipulate the virtual contents to cut like a silhouette around the hands. So that will allow the hands appear to be on the top, but in fact, they simply do the reverse trick by actually cut the virtual contents so that the hand appear to be on the foreground. Yeah. But with the Apple iPhone 10, I believe they have built in some depth sensor. Okay, I think that one can do slightly much more different. With the price I have, I hope they do much more different. Which is actually, you can detect the foreground natively. So that is, the iPhone is miniaturized Kinect on top of it. So you can detect the foreground. In that case, it's actually very easy to get the hands out. Okay. Because nothing worse than illusion that actually, oh, this is look real, and then suddenly you walk past it, and then the whole thing kind of get in front of you. Okay, so, but this is with the technology that they explore the concept interaction based on the current technology they have, which is the same mentality that you should use for the assignment now. Even though we have all these advances, you might have not the time to master them all. So you just use what you have, okay, and then what you're good at, and then basically what you feel comfortable with, and then build the rest of it in the design component. In the report, okay. Now, the next thing is that actually show the last piece here is called transitional interface. This one is actually spin off the same work, the little cardboard cartoon, but this one actually blur the line between outside augmented reality and inside virtual environments. Okay, so this one is actually you look at the book. This is a concept called Magic Book, which has helped launch the AR kits. Okay, AR2 kits. And then basically they wear some kind of glass, and then suddenly they're inside the world. Okay, inside the world that they actually see. Okay, so that's you can see here the spectrum that I showed before, the real world, the virtual world. This one is go translate into those frames back and forth. Okay, and now here we come when Mark is still young, still we the same at the lab in Seattle. So the concept here is very simple. You read into a book that on the right-hand side has a Japanese character. I'm pretty sure he cannot read them, but he definitely, the project pitched as a concept as a magic book. So you can still read part of it. The other part of it, usually a picture or everything else, is actually replaced by his technology, which is a simple marker. Okay. So this is really about interface design. It's about extend the physical presence of what already on the print further, and then it's into the digital world. So that's why he has his handheld things here again, with a camera stitched attached to the front. At the bottom here, it'll look like a weight. That is actually help him with the weight, because otherwise the front will be too heavy. And it also built with a 3D-dimensional gyro, okay, with help with tracking. And this is a view from inside. You can see this character. This is very quite popular then, because nobody really know AR before. No, not commonly seen. Okay. So now we are talking about moving into space. Okay, so this is what he showed before is a typical AR. Now you're looking at this Japanese house, and maybe some text there that you read, and then now you click a button on your controller, then you translate inside. What that means that all the display will project those. Okay. The reason they can do this because you remember when we talk about AR, we have video see-through mode. You can cut off the real world, even though you cannot see through because all the real world comes from that camera in front of you. You just simply cut that feed and project the virtual contents. Even though you're still on the side, you can still see a lot of things, but that's what image you can see. So that's allowed, for example, you see something outside, you want to dive in. Okay, this is really in theories of exploring what the benefits are. Okay, this has not been fulfilled in terms of people explore a lot into this. It's still, right now the track is still go to track. It's still either inside or it's actually outside like AR. Okay. This is one of the few work that we're looking at the crossover, in and out, what can you do? Okay. And of course it's quite fun to have this as a few people looking together. Okay. Yeah, so this one is I play around with size. I mean, some of the VR demo that you play around on the Oculus Store is you will see that they transport you into a very small, tiny man or tiny person. Yeah, so that's the kind of give you an experience of immersiveness. Is not necessarily been a real world scale. It could put you in a space like what it looked like to ride, for you to be part of the blood cell that go into your blood. So you will go woo, riding around, looking at different organs and those kind of things. So this is we're talking about different avatar. Okay, so of course avatar at that time looked like that. But with current technology, this is practically your face, because they can capture your face now. That's what Facebook is aiming for. One of the problems with AR is a social connection, because when you put AR on it, practically you don't actually talk. How you actually get the social content, which is that what Facebooks are making their fortune on. Maintain those inside that space, and that's why Facebook. It become clear to industry now why Facebook invests the money in this space. Before it was like, maybe he has nothing else to do. Maybe he has too much money. Why would spend $2 billion by Oculus? Now very clear, he creating this space. Try to go into this space and be the first. Okay, to occupy this space, social, but this one is immersive social networking. So you could be looking. They showcased this a couple of years ago already, when they actually see their avatar talking inside a new medium. So, and if you see the Hollywood movie called Surrogate, Bruce Willis, if you look for that, basically the whole world is actually people are on inside some kind of metric table, and then they basically transport into one people, and people is actually a robot talking together, and then they're really actually face to face. So basically, you could be talking a beautiful lady, but turn out to be a fat guy. So, so those kind of things. So that's the kind of momentum in which social is. It might be getting in slightly. Just like right now, you don't really know if you find a stranger on Facebook, whether that's their photo or not photo. Yes. All right, thank you. So let's see, we make a way to, most of you are in tutorial 1, I think. Yeah, tourism in what part of tourism? So you focus on something?
Not specific to tourism, but I'm looking more environmental tourism, like it'll be cartoony and stuff.
Oh, yeah. I mean, those contents are there.
Yeah, but I'll take you to like a virtual environment. But I'm trying to think of ways to interact. I'm thinking like maybe some kind of panel where you can change your environment or something, and it'll